In this video, we are going to be looking at what cap theorem is, and we're going to be trying to understand some basics about cap theorem. So I have this blog article from educative.io, right, where they've explained it pretty well. Right, so I'm going to be following this. I will also link this blog article in the description below if you want to go check it out and read it entirely. In this video, what we would be covering is we would be covering what CAP stands for, and we'll be trying to understand those in detail, right? So because once we understand those, then we can actually dive into what cap theorem is and and how it works and all that. Let's get started. Let's first see what are distributed systems, right? Just a little bit intro about distributed systems. If you have more than one machine which is trying to talk between themselves, you have a distributed system. It's as simple as that. On a very high level, there is a lot more to it. But to understand the very basics of it, if you have more than one machine, right, one server, right, an EC2 instance or whatever, like whichever cloud you're using, right? If you have more than one machine and they're trying to talk between each other, you have distributed systems, right? It's as simple as that. Now, let us see what consistency, availability, and partition tolerance means, right? The CAP in the cap theorem stands for consistency, availability, and partition tolerance. So let's see what they stand for. Consistency. In a consistent system, all nodes see the same data simultaneously. If we perform a read operation on a consistent system, it should return the value of the most recent write operation. The read should cause all nodes to return the same data. All users see the same data at the same time, regardless of the node they connect to. When data is written to a single node, it is then replicated across other nodes in the system. So what is it trying to say, right? Let's go to a diagram. So let's say you have an SQL server, right? You have MySQL or PostgreSQL, whatever it is, and you have that installed in 3 machines. So what you're saying, okay, now whenever I write, I will write to machine 1. So again, consistency cap theorem only applies when you're in a distributed environment. If you're in a single environment, like let me take an example where there's a single machine. Now let's say there's a machine 1 which is SQL, and let's say we have a user. Now if the user is writing data to this SQL machine, and in the next millisecond, right, he's trying to fetch that data. So whatever he wrote, he will get the data back. So this is what consistency is. You write a piece of data or you update a piece of data, and in the next millisecond, if you're trying to get it back, you should have the same data. So now in a single machine, there's no issue at all, right? Because there's a single machine, you write it, and no matter what, if the write is done and you trying to ask the data back in the next millisecond, you would have the data back. But now let's see how this changes when you have multiple machines. Let's say now you have multiple machines. What is happening is that these machines are talking to each other. Machine 1 is talking to machine 2, machine 2 is talking to machine 3, they're talking to each other. Now what happens is, let's say my write, so now you're only writing on a single machine, right? You're not saying, okay, I'll write it on all 3 machines. Let's say you're writing it on machine 1. Let's say you're writing some x equal to 5, some data, right? It doesn't matter what data point it is, right? Let's say you're trying to write some data. Now you're writing it to machine 1. What I've done is I've configured these machines so that whenever there's a new write or update, like new entry, write, or an existing entry has been updated, whatever the case is, these machines will talk to each other and get the updated value. So I am writing x equal to 5. In this machine, now I have x equal to 5. What happens is, as soon as it's written, now machine 1 will tell to machine 1, hey dude, I've gotten a new value x equal to 5. Now what machine 2 will do? Machine 2 will also say, okay, x equal to 5. I'm also entering that value. Machine 2 says I will also have x equal to 5. Now again, machine 2 says to machine 3, dude, machine 1 gave me x equal to 5. Write that with you. Now machine 3 is also saying, okay, I will write x equal to 5. After this, now these 2 machines have talked to each other through the network, right? This is a network. Let's say now they're trying to talk to each other through a network. This is also a network. So what happened is, now how did machine 2 and machine 3 get the value 5? They are talking through each other through a network. So once they've talked, now all of them have the x equal to 5. Now let's see when he's reading, when the user is actually reading, he is reading from machine 3. For example, he's saying, now I want to read x, but I'm reading from machine 5. What will machine 3 will do? Machine 3 will say, okay, now x's value is 5. I'm giving this value back to the user. So whatever he's written, now this value he has gotten that value back. So what consistency says is that no matter which machine you write to and no matter which machine you read from, Once you've written it, in the next millisecond, if you're trying to read it from a different machine, you should have the updated value. We're assuming that this takes 0 milliseconds. As soon as you've written, magically, let's forget about how it happens, right? Let's just assume magically, as soon as you write to a single node, it won't even take 1 millisecond for this value to go to other two machines. Let's assume that, right? That's not the case, but let's assume it. In this case, you say that this system is a consistent system. Let's say, for example, now machine 2 had to talk to machine 1, machine 3 had to talk to machine 1 or machine 2 to get the updated value. Let's say it takes some 20 milliseconds or 30 milliseconds for these to talk to a different machine and get the value, which is what happens in a real world, right? In real world, there's no magic. It doesn't happen. In real world, there's no magic here, right? In real world, there is some kind of latency, right? It takes some time, 20 milliseconds, 30 milliseconds, 50 milliseconds, whatever it is, for this machine to talk to the other machine and get the updated value. In that case, let's say, for example, it takes 50 milliseconds for machine 2 to talk to machine 1 and take the value. Now, we've written x equal to 5 to machine 1. Now, we don't have x equal to 5 here. It takes, let's say, 50 milliseconds. Once you've written, in the next millisecond, if your user is asking for the value x, now machine 2 will say, dude, I don't have any x, right? I don't know what x is. It'll take 50 milliseconds for machine 2 to actually go to machine 1, fetch the value and write it back here. It's some example, right? So in this case, right, even though you've written x equal to 5 to machine 1, when you try to query machine 2 within the next millisecond, you did not get x equal to 5. So this is an inconsistent system. So consistent system means you wrote x equal to 5 to machine 1. If you query machine 2 and machine 3 within the next millisecond, they also give you back, when you try to read x, they tell you x is 5, right? That is a consistent system. But in an inconsistent system, you wrote to machine 1, you wrote x equal to 5 to machine 1, but when you try to ask the value of x to any of machine 2 or machine 3 within the next millisecond, now they don't have the value, right? Because it takes some time for them to get it. So this is an inconsistent system. In this case, the technical term is actually called eventual consistency, because they don't have it in the next millisecond, but eventually after 50 milliseconds, they would have the data. So it is called eventual consistency. So now this is what consistency is. And then this is what they've tried to explain here. Let's see what availability is. When availability is present in a distributed system, it means that the system remains operational all of the time. Every request will get a response regardless of the individual state of the nodes. That means that the system will operate even if there are multiple nodes down. Unlike a consistent system, there is no guarantee that the response will be the most recent write operation. Let's go back to our drawing board. Okay, let's assume now x already has a value. Now let's say the existing value of x is, let's say, 9. Now this is there in all three machines. Now what happens? The user is saying, okay, x's value is not 5, x's value is not 9, x's value is 20, or let's say 2. Now user is saying x's value is 2 and he's trying to update machine 1. Now what happens is, let's say machine 1 has written x equal to 2 to machine 1. Now again, as we know before, it takes some time. It takes that 50 milliseconds for machine 2 and machine 3 to get that value 2. But let's assume before that 50 milliseconds, if machine 2 is now destroyed, now machine 2 and machine 3 won't be able to talk to machine 1. But now when the read goes through machine 2 or machine 3, you will be giving the value of 9. Right? This is an inconsistent system, but it is an available system because you are still there to respond to the queries of the user and give some kind of value back. Let it be an outdated value, but some kind of value back. Now this is an available system. But let's say in this case, let's take the case of a single machine. You wrote x equal to 2 here. But when you're trying to read it, now this machine was also somehow destroyed. Now it's destroyed. Now if the user tries to read, he won't have a place to read from. So he won't even get an outdated value. He says, there's no machine. I don't know what you're talking about. Now this is an unavailable system. Whereas here, even though machine 1 was destroyed and you lost the updated value, you still had an outdated value through which your system was available. People could do something to your system. People could user is trying, they're reading, okay, x is again 9. Let me try to now write this again. Now when they try to write this again, since your system is available, it is available to take new things. Now this x equal to 2 will be updated here, and in 50 milliseconds, machine 3 would also get x equal to 2. Now it becomes eventually consistent but your system is available. Whereas in this case where you had a single machine and you had a single SQL, as soon as you wrote, if the machine is down, you're not going to be available, right? Because you have no data. Like, where would you go and get the data if there's no machine? So this is an unavailable system. Whereas the system where you have 3 machines, this is an available system. So this is what they mean by availability. Now, partition tolerance. When a distributed system encounters a partition, it means that there is a break in the communication between nodes. If a system is partition tolerant, the system does not fail regardless of whether messages are dropped or delayed between nodes within the system. To have partition tolerance, system must replicate records across combination of nodes and networks. What are they trying to say here? Let's go back to our board. Now machine 1 is talking to machine 2 and machine 2 is talking to machine 1. What are they talking about? Now let's say X's value is 9 in all the 3 machines. So what they're saying is that assume that this network is not there. Machine 1 is not able to talk to machine 2. And machine 2 is not able to talk to machine 1. What partition tolerance says is that if you write X equal to 2 in machine 1, even though there's no network communication between these, if you try to read from machine 2, it should somehow magically give you 2. If it does, then it is a partition tolerant system. If it doesn't, it is not a partition tolerant system. As in this case, it won't, right? Because this is not a partition tolerant system. As soon as there was a partition means there is a break in the network communication. As soon as there's a partition between these machines, right, the write was given to machine 1. Now machine 2 has no idea what it is. Machine 2 and machine 3, they still are talking to each other. And they still agree, okay, the value of X is 9. But little do they know that the value of X was actually changed to 2. So this is not a partition tolerant system. There was a system where even though this network was broken, let's say somehow X got the value that X is 2, and machine 3 also got the value that X is 2. In that case, now even though there was no network here, somehow magically they found out the X's value was updated to 2, and when the reads come, they were able to give back 2. Now this is a partition tolerant system. Let's recap, right? Consistency, availability, and partition tolerance. Consistency says that no matter which machine I write the value of X2, in the next millisecond, if I ask the value from any machine, not just the machine that I wrote to, doesn't matter whichever machine, right? Machine 1, machine 2 or machine 3. If I ask the value of X within the next millisecond of when I'm writing it, X should have, these machines should give the user the updated value. That is consistency. What is availability? Availability says that, let's say now we've returned to machine 1, but machine 1 went down. So what is availability? Availability says that, let's say I've written X equal to 2 to machine 1, but that value has not been replicated to machine 2 and machine 3, right? They still have the old value of 9. But let's say now this machine is destroyed for some reason, right? Machine 1 does not exist anymore. In that case, at least your system is available to give a value of 9 to the user and do something else, right? You're not saying, okay, now there was an updated value, but I don't know what the updated value is, so I'm not going to serve you, right? I don't know what the updated value is, so I want to be consistent and I won't give you the data. Now that might be a consistent system, right? Because you're saying, okay, I don't know what the updated value is, I'm not giving you the data. So you're still maintaining some sort of consistency, but your system is not available. So that is availability. The third is partition tolerance. What does partition tolerance say? Partition tolerance says, if you see here, there's no network here, right? Because machine 1 and machine 2 they're not able to talk between each other. Even in that case, if your system is able to maintain consistency, then it is a partition tolerant system. Let's say I wrote X equal to 2 here, but machine 2 is not able to talk to machine 1. Even though it's not able to talk to machine 1, machine 2 somehow magically figures out that the value of X is 2. Now this is what is called partition tolerance. This is what consistency, availability, and partition tolerance means. So yeah, that's it for the video. I will link this article, a couple more articles, and maybe a couple more YouTube videos for you to better understand these concepts. But understanding these concepts is very, very important, because these concepts are what distributed systems are built on top of, right? You need to understand these concepts very well to make great systems. All right. So understand these. I'll link YouTube videos so that you can understand them better, and see you guys in the next video.